Okay, for number 16, we want to know a disadvantage to selecting a cluster sample. Remember, a cluster sample is you split the population into different groups, like mini populations. You randomly select some of those, and you sample everyone in those clusters. So the issue with this one is, if we get a cluster that's not representative of the seniors, then we have an issue. And that's what could happen here. We don't care. The sample isn't going to be too large. Larger samples decrease variability. As long as you have a good sample, it's a good thing. All right. 17. Which of the following provides evidence? So, new drug causes relief. Well, we're going to look at the difference between the new drug and the placebo. And it has to be statistically significant, large enough that it's not likely due to chance. That would give us evidence that the new drug provides relief significantly at a higher rate than the old drug. All right, question 18 gets into a short answer question, deals with blocking, and they give you these two different blocking schemes. Remember, we block to create similar conditions. So blocking scheme A is what I want to pick, because now all the trees, the dwarf trees that I plant in this block, are going to be close to the forest, getting more shade, and all the ones away from the forest in block B are probably going to be getting more sunshine. So I can see if does the shade or sunshine have an impact on their growth. And then in part B, what's the purpose of randomization? We want to reduce the effects of any potential confounding variable that we may not control for. So it could be amount of sunlight, it could be soil quality, fertilizer in the soil. That's what that's going to do, is make these groups essentially equal except for the treatment, what we're imposing on the plots of land in this case. That's it. So it's going to equalize all these other potentially confounding variables. Okay, question 19. This is now moving into chapter 5, probability. What's the probability it will be greater than 40? So this is a binomial situation because I have a fixed number of trials. They're either having their bachelor's degree or they don't. Each person having a bachelor's degree is independent of the next. I already went over the fixed number of 50. Probability somebody has a bachelor's degree is 31%. So this is a fancy way of just saying 50, choose 40. If you look at your formula sheet, this is on there. We have 40 successes, 40 people have their degree, and 10 people don't. These are complements. Here, this is switched. We don't have the right sample. I'm sorry, the fixed number of trials is incorrect. Fixed number of trials is incorrect. And this just represents, I'm not sure what this represents. 50 people having a bachelor's degree. I'm not sure why you're multiplying it by 40. It doesn't even make sense. Okay, question 20. Are B and S mutually exclusive? Okay, part D and E have to be gone right away, because if you have mutually exclusive events, the probability of them both happening at the same time is 0, so that would be out. If I was just strictly guessing, I see 5 twice, I see 62 twice, I'm probably not guessing B, I'd probably guess A or C. I set up a two-way table that helped me understand this a little bit, and that led me to see that there's a 5 out of 78 chance that they are in band and on a sports team. 21. What's the probability it takes 3 rolls until a player doubles? So you got to recognize this is geometric. How long until the first success? So it's not double, then double. Multiplication's commutative, so it doesn't matter if I write it like this or write it like this. I'm going to get the same product. But I have 2 failures and 1 success. That's why this is choice D. 22, to be honest, I got it wrong at first. I put choice A because I didn't think about the order. That means Adam could be selected first, Ella second. So it'd be 1 out of 5 times 1 out of 4. That's 1/20th. Or Ella could get selected first and Adam second. That's 1/20th. If I sum those up, there's a 1 out of 10 chance that Adam and Ella are selected. Okay, question 23. This is a great question. This is just dealing with independent random variables. So this is chapter 6. I have to recognize that their times are independent of one another. So the standard deviation of the sum of the 4, it would just be adding variances. I guarantee if you add these 4 numbers, that answer is here. It's wrong, but that's why it's there. The other thing to keep in mind is, if I'm just being logical, I can't have less variability than any one individual if I have 4 individuals, so choice A doesn't seem to make any sense. And whatever the one is from that you get from just adding it, it's the 3.32. That can't be the answer. So even if you had to kind of guess, at least you've narrowed it down to 1 in 3 shot. You're just doing that calculation, taking the square root, because you're trying to find the standard deviation. Ends up B. All right, question 24 deals with a discrete random variable, number of defects in this product. I really like what they did in part A. I had to read it a few times before I really understood what was going on. But here's the good news. Say you don't understand how to do A. Make up A. Literally make it up. Make up some probability distribution and make sure the probabilities add up to 1 and are all between 0 and 1. The reason that's beneficial is because then you can do the rest of the question and get credit for part B and C. If a quarter has more than 2 defects, so the reason this is important is that's given. Given it has more than 2 defects, it's sold and cannot be sold and it's discarded. More than 2, so I'm getting rid of these, and I'm only looking at the 92% of the fat quarters that are sellable. So that's why I'm taking the probability of 0 defects as 0.58 divided by the 0.92. Again, the 92% is coming from the ones that are not defective to the point where they can't be sold. And I'm doing the same for 1 and 2 defects. Determine the mean and standard deviation. You have to show your work. You can do the shortcut in the calculator, and I'd encourage you to do that. What do I mean? Plug the values in list 1, the probabilities in list 2, and then run one variable stats on L1, L2. That will get you your mean and standard deviation. I would absolutely do that. You just have to support it with the work. These formulas are on your formula sheet. This is just a weighted average and kind of a weighted standard deviation. The value minus the mean squared times the weight. So that's A and B. Part C, they want the mean and standard deviation of the selling price. Well, they sell for $5 a piece minus the $1.50 per defect. So what we're doing is just substituting in those values, the mean and standard deviation. This should actually be 0.49. Oh, no, it shouldn't. Wrong data. So 0.4, 0.66. And I'm not adding and subtracting the 5 here because shifting doesn't affect variability. So you couldn't see that, but I'm not adding and subtracting the 5 here. All right, that's it for chapter 6. 25 through 20 through 30 are chapter 7. This is kind of tricky. What is the mean of the sampling distribution? Well, the mean is just the true mean for the first group and the true mean for the second group. Well, if I just average the numbers 1 through 6, I get 3.5. 1, 2, 3, 4, 5, 6, I'm averaging, I get 3.5. So it doesn't matter if I'm rolling 10 times, 5 times, that's going to be the same average. Here, sample mean, so this is where we're talking about the central limit theorem. If the population is normally distributed, then the sampling distribution will always be normally distributed. So A and B are out. D and E are out because the sample size is greater than or equal to 30, so the central limit theorem applies, but it does not in C. All right, 27, which is going to create a biased. Biased means, remember, the mean of the sampling distribution doesn't equal the population mean or the population proportion. That's what this is saying. The expected value, that's a fancy way of saying the mean of the estimator, the mean of the sampling distribution is not equal to the population mean. All right, question 28. What's the mean of this sampling distribution? It's the true proportion for A minus the true proportion for B. All right, question 29. What's the best interpretation of this 0.05? Well, this is the mean of all the sample proportions. And that's what choice I'm looking for. The mean of all the resulting sample proportions of cell phone screens with a screen defect is 5%. It's got to be for all sample proportions because it's from the sampling distribution. Okay, question 30 is on the next page here. Part A, this is just talking from section 7.2. When you have proportions, CVS, going through the 10% condition, your large counts condition. Remember, don't use symbols, just go right to the numbers. You do have to show the actual calculation. So then I take the sampling distribution, calculate a z-score, use my standardized values to get this a little less than 9%. Then part B, it says describe the sampling distribution of the difference. So I'm looking at the difference in proportions, the variability with my 10% condition, the standard deviation of the variability. So you have the two separate groups, 0.034. And because the large counts condition is met for that second group, then the sampling distribution is approximately normal. My apologies, you couldn't see that. So in conclusion, the sampling distribution is approximately normal. There's your shape. The center is 0.04. The variability is 0.034. And then in part C, they want to know what's the likelihood that you're going to differ by more than 5. So it could be 5% or higher, or negative 5% or lower. So you have to calculate a couple of z-scores here, and then do normal CDF twice. Once for the negative 2.65 from negative infinity to the negative 2.65, plus another normal CDF from 0.29 to positive infinity, both with mean and standard deviation of 0 and 1. I hope that this was helpful. That's the rest of the video solutions.